So we're going to look at the final exam review for quadratics. We're solving quadratic equations. There are three methods that we use to solve a quadratic equation. They are square roots, factoring, and the quadratic formula. What you'll see is as we go through these, certain methods are a little bit faster and easier than other ones, but it just depends on the way the problem's set up. So if you look at number one, the first thing I notice is the only x term I have is just an x squared. There's no other x term, which means I'm not going to factor and I'm not going to use the quadratic formula. Even though the quadratic formula would work here if I moved everything to one side, it's going to be definitely more straightforward to use square root. So what I'm going to do then, to use a square root, we first have to get x squared all by itself. So I'm going to divide both sides by 8. So what I get is x squared equals 12. 96 over 8 is 12. And then the reason why this is called square roots is because I take the square root of both sides. So if I take the square root of x squared, I get x. And if I take the square root of 12, and what we have to remember about square roots is when I square a number, a positive number, it stays positive. If I square a negative number, it becomes positive. So when we have our answer, we have a plus or minus of whatever that answer is, because both of them, if I plug them back in the original, should work. And what I need to do then is break up 12. So I'm going to split that into 4 and 3. And the square root of 4 is 2. So this answer is x equals plus or minus 2 root 3. So the square root method was very straightforward there. And that's the method I would use when I have just an x squared and no other x term. Similar for number 2, what I notice is I just only have an x squared, so I'm going to try and get that x squared by itself. So I'm first going to add 4 to both sides, so I get 1/2 x squared equals 4. And then to get x squared by itself, there's a couple ways to go about it. The easiest way, I think, is to, instead of dividing both sides by half, although that works, the easiest way is just to take both sides and multiply by 2. The reason multiplying both sides by 2 works is because 2 times a half becomes 1, and that's now our coefficient for x squared, which is what we want. If you divided both sides by half, you'd get the same thing. The only problem is sometimes we say 4 divided by half is 2, when in reality 4 divided by half is 8. So whichever method you want to do is fine. I just prefer multiplying when it's a fraction out front. Either way, now I'm going to take the square root of both sides, so I get x equals plus or minus, and then I'm going to break 8 into 4 and 2. So the square root of 4 is 2, so this becomes x equals plus or minus 2 root 2. Number 3, looking at the way it's set up, again, it looks, everything's on one side, so maybe I can use the quadratic formula. That will definitely work here. But I notice I don't have an x term, so I'm actually going to use square root. So I'm going to get x squared by itself. So I'm going to subtract 243 from both sides. So I get negative 3x squared equals negative 243. Then I'm going to divide both sides by negative 3. So I get x squared equals 81. And then if I take the square root of both sides, I get x equals plus or minus 9. That was a perfect square, so it works out to a whole number. And number 4, again, noticing I only have an x squared, I'm going to use square roots again, so I'm going to add 20 to both sides. So 4x squared equals 72. Divide both sides by 4. So I get x squared equals 18. Take the square root of both sides, I get x equals plus or minus, and then I have to split 18 into 9 and 2. Because 9 is a perfect square, so you should get plus or minus 3 root 2 for your answer. Now for number 5, again, I'm going to always look at the problem and figure out what method would be the most useful. I could use the quadratic formula here. Everything's already on the left side. Everything's in standard form already, so I can go ahead and do that. But I like to first check if it factors. So I'm looking for 2 binomials that multiply to get this expression. Should be equal to 0. So what I notice is I have x and x, and then I need numbers that multiply to positive 7 but add to negative 8. The combination that works would be minus 7 minus 1. So I have my 2 binomials factored. Then I'm going to solve this, to finish this, I'm actually just going to set each factor equal to 0. So x minus 7 equals 0 and x minus 1 equals 0. And then solve each equation separately. So add 7 to both sides for the first one, and then add 1 to both sides for the second one, so my 2 answers should be 7 and 1. For number 6, it looks a lot like number 5, so it's already in standard form. I have x squared plus 9x minus 3, and I would maybe look to factor that, but I think about this, are there any factors that multiply to negative 3 but add to 9? And there aren't any, which means it's not going to factor. So the method I'm going to use here is the quadratic formula. So I'm going to first identify a, b, and c. A is the number in front of x squared, which is 1. B is the number in front of just our x term, which is 9, and c is that constant term, which is negative 3. And then what I like to do, just so I'm careful with my signs and what goes in what places, I like to write out just a blank, empty quadratic formula. So what the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But wherever a, b, and c were, I just keep an open, empty set of parentheses. Now I just put my numbers in the correct place, so it's the opposite of b, so 9 goes in that first set of parentheses, plus or minus the square root of b squared, which is 9 squared, minus 4 times 1 times negative 3, all over 2 times 1. So that's step 1. Just put the numbers in the correct place. Just be careful about what's inside parentheses. And then I like to just handle the number out front, x equals negative 9 plus or minus. And then I do what's underneath the radical really in 2 steps. So first square that b, which is in this case 81. And then I bring down the minus from the inside of the square root. And then I multiply the 3 numbers together. So I've already dealt with that minus up front, so I really just multiply 4 times 1 times negative 3, which is negative 12, all over 2 times 1, which is 2, and then all I need to do is correctly add or subtract those numbers on the inside of the radical. So negative 9 plus or minus, and then 81 minus negative 12 is the same as 81 plus 12, which is 93, all over 2. And then the last thing I need to check is if 93 has any perfect square factors. It does not, so that would be my final answer. So that's kind of the process for the quadratic formula. Just be careful with how you set it up, and just don't try and do too much in one step, because you might lose track of what positive or negative here and there could really make a difference in your answer. Number 7, first look to factor, but notice there's a negative out front of our first term, which usually we're not used to seeing. So what I like to do in this case is just multiply everything on both sides of the equation by a negative, and all that really does is make the first term positive but changes the sign of all the other terms, so it doesn't change my answers. It just puts it in a format that we like a little bit better or are used to seeing. So then I'm going to try and factor that, see if there are any factors that multiply to be negative 9 and add to 2. There aren't any. You can check every combination if you want. It's not going to work, so then I'm going to have to use the quadratic formula. So then I identify a, b, and c. So a is 2, b is negative 5, and c is negative 9. And then I'd like to write a open, empty quadratic formula just like the last one. So there it is. And then I just put a, b, and c in the correct place. So the first blank should be a b, and then b in the underneath the radical squared, minus 4 times a times c all over 2. And then I like to just handle each part kind of as I come to it. So x equals negative, or opposite of negative 5, which is 5, plus or minus, and then I handle what's underneath the radical in 2 separate steps. So first I square the negative 5, which is positive 25, and keep the minus, and then I multiply 4 times 2 times negative 9, which gives me negative 72, all over 4, and then I deal with that minus negative. So I have 5 plus or minus 25 minus negative 72 is the same as plus 72, which gives me 97 under the radical, all over 4. 97 is not a perfect square, nor does it have any perfect square factors, so that would be my final answer. And then for 8, already in standard form, I have 2 different x terms, so I'm going to have to either factor or use the quadratic formula. I'm going to look to factor first, and this one actually does factor. And usually you see 4x squared, you probably check 2x and x, but here's what I'm thinking about. If you think about 4x and x and 1 and 3, which are the only factors of 3, that's going to be the only way I can make 13. What I mean by that is if I check my outside, that would give me 12x, and my inside would give me x. So 12x and x can make 13x. The only problem is I need the middle term to be negative 13x, which means I need a negative 12 and a negative 1, which would make the negatives, make the 2 signs in both my binomials negative. So checking those 2 factors works. 2 and 2 as my first factors in each binomial wouldn't work. There's no combination that would. So that's the only one that works. So then once I have my 2 factors, I'm going to set each factor equal to 0 separately, and then solve each one. So add 1 and then divide both sides by 4. So I get x equals 1/4 as an answer. And then add 3 to both sides in my second equation, and x equals 3 as my answer. If you use the quadratic formula, you should get the same answers or the same numbers, just in a slightly different format, because when you try and use the quadratic formula, and if your original equation could have been factored, what you'll notice is you'll always get a perfect square underneath the radical. In this case, you would have gotten one too. So that's just one tip. If you use the quadratic formula, what's underneath the radical is a perfect square. That means you definitely could have factored that if you wanted to. Number 9, first I'm going to look to factor if possible, and then if it doesn't factor, I'm going to use the quadratic formula. So looking at this, I'm going to see if I can factor it. So I have 3x squared, so I'm going to use 3x and x as my first term in each binomial, and then factors of 10, that would make this work out to be 11 in the middle. It's got to be 2 and 5 in this case, and here's the check, right? If I check my outside-inside product, my outside, 3x times 2 is 6x, my inside would be 5x times x, which is 11x, both positive, so that works for my middle term. So my two factors are correct, and then what I do from there is just take each factor and set it equal to 0 separately, and then solve each equation. So 3x plus 5 equals 0, I would subtract 5 from both sides, so 3x equals negative 5, and then divide both sides by 3. X equals negative 5/3, and then x plus 2 equals 0, I would subtract 2 from both sides to get x equals negative 2, and there should be your two answers from factoring. Again, if you use the quadratic formula, you should get the same answers. Yours might look a little different. You should maybe have something plus or minus a number, but that should be a whole number, because what's underneath the radical should be a perfect square. Number 10, again, I'm going to try and factor first. I think I'm more comfortable factoring, so I try that first. If that doesn't work, then I use the quadratic formula. So I'm looking at this. If it factors, it'll factor in two binomials, which you'll notice is I highlighted the x squared and the x, just showing that there are two x terms, so using a square root wouldn't make sense. And none of those numbers, one thing is, what I'm also checking before I set up my two binomials is if there's any greatest common factors. None of them up to this point have had any, so I'm going to split this into x and x. And then the only pair that works for multiplying to be negative 36, but adding to be negative 15 is negative 3 and negative 12. So then I can set each of these factors equal to 0 separately, and then solve each equation. So I'd add 3 to both sides, and I get x equals negative 3 for x equals positive 3 for the first answer. Then add 12 to both sides, I should get x equals 12. So those would be my two solutions for number 10. Like I mentioned before, for number 11, I said when we were doing number 10, check if there's a greatest common factor. One thing we maybe have a hard time remembering is if I have a binomial, it may factor. What I notice is I have two x terms, so I can't just move one term over and then take the square root. Instead, I'm going to look for a greatest common factor. The only greatest common factor between these two terms is an x. So if I factor out an x, although it looks slightly different, I really am done factoring, and I have an x times a 7x minus 2 equal to 0. So what I can do is just set each factor equal to 0, much like if it was two binomials. So x equals 0 is already solved. There's my first answer. And then to solve the second one, I would add 2 to both sides. Then I would just get 7x equals 2, divide both sides by 7, and I get x equals 2 over 7. So what we have a tendency to forget is that when we factor out an x, we also set that x equal to 0, and that gives us our second solution. So you should get 0 and 2 sevenths. Number 12, no greatest common factor between the three terms. There's two x terms, so I'm going to try and factor first. So x squared is x and x, and then factors of 6 that add to 7. You should get positive 6, positive 1. You could use the quadratic formula here, but I think that's way more work for something that factors really easily. Then I can set each factor equal to 0, and then solve each equation separately. So subtract 6 from both sides here, I get x equals negative 6, and then subtract 1 from both sides here, and I get x equals negative 1. So those would be my two answers for number 12. Then the last few problems here, again, notice there are two different x terms in all of them, so I'm really only going to use factoring or the quadratic formula here. So if you look at number 13, it may or may not factor. If you want to try all the combinations, you can. What you'll notice is there isn't one that actually works. Make sure you're careful when you check. So I'm going to use the quadratic formula here. So first identify a, b, and c. It's already in standard form, so a is the number in front of x squared, b is the number in front of x, and c is the constant term. And then the next thing I like to do is write an open, empty quadratic formula, same as I did in the other problems. And then I'm just going to fill it in with the appropriate numbers. So b goes in the first blank, b also goes in the first blank underneath the radical, a, then c, and then a in the denominator. Then first deal with that negative 2, or opposite of 2, plus or minus, and then I square the 2, which is 4. I keep the minus, and then I multiply 4 times 2 times negative 1, which is negative 8. So really what happens underneath is I end up with 4 minus negative 8. That's the way that I like to handle it. It helps me really keep straight what happens with that, whether it becomes positive or negative. If you want to treat that as a negative 4 multiplied by 2 times negative 1, you should end up with positive 8. That's fine. You end up in the same place I do, just a slightly different method. So what I should get is negative 2 plus or minus root 12 over 4. A lot of us would be tempted to stop here, but we have to make sure that that radical is as simplified as possible. And it's not. It has perfect square factors, so I'm going to break that into 4 and 3. So I can call this negative 2 plus or minus 2 root 3 over 4, because the square root of 4 is 2. That's what's on the outside, and then root 3 stays on the inside. You can leave it like that, or if you notice that all of those numbers divide by 2, you can divide them all by 2 and get negative 1 plus or minus 1 root 3 over 2. Those are both the same answer. I would accept either. It's just depends on if you want to go to that last step or not. Now, if it's a multiple choice question, you might have to. That's up to you to be able to recognize that. But if you can get down to, negative 2 plus or minus 2 root 3 over 4, you really know how to use the quadratic formula. You just maybe didn't think to check common factor between all those. 14, again, I'm going to first look to factor. So 3x and x equals 0. You can use the quadratic formula. It will work. But this one actually factors. Just tried a couple different combinations in my head, and I saw that there would have to be 3x minus 1, x plus 1. And the idea there is I need factors of negative 1, which are 1 and negative 1, but I need to put them in the right place so that my outside-inside adds to 2, and it does in this case. So then, once I have my factors, I'm going to set each one equal to 0, and then solve each equation. Add 1 to both sides. 3x equals 1, divide by 3, x should be 1 over 3. I know we're not always super comfortable with that, but it is it's a correct answer. It's a preferred answer for me than a fraction, so that's how I would leave that, 1/3. And then the second equation, x plus 1 equals 0, I just subtract 1 from both sides, and I get x equals negative 1, and that would be solving that one by factor. And then 15, what I'll notice is what we have a tendency to do is just try and, use the quadratic formula, but not really pay attention that this problem is not in standard form yet. So the first thing I'm going to do is add 10 to both sides, get everything on the left. So I get x squared minus 14x plus 10 equals 0. And then I'm going to look to factor that. Are there any factors of 10 that add to 14? No, there aren't. So then I'm going to set up the quadratic formula. So I'm going to write my open, empty quadratic formula here. And then I'm going to put the numbers in the correct places. So B, B, A, C, and A. Go in that order. And then I'm going to deal with the numbers. So negative 14 is 14, plus or minus. And then I like to square that negative 14. Negative times negative is positive. Minus, and then I do 4 times 1 times 10, which is 40, all over 2. And then subtract what's going on the inside, so 14 plus or minus 156 over 2. And then the last thing I have to check is if anything in that radical can be simplified at all. So 156, the pair that will make the most sense would be 4 and 39. 4 is the only perfect square factor of 156, other than 1. So then if I break that into 4 and 39, I'd get 14 plus or minus, and then the square root of 4 is 2 root 39 over 2. And I would accept that answer. The only other thing you could do is reduce everything, the 14, the 2, and the 2 by 2. And you'd get 7 plus or minus root 39 all over 1, or just 7 plus or minus root 39. And then the last problem here, already in standard form, I'm going to look to factor. It actually factors nicely. So I have 2x and x multiplied to 2x squared, and then factors of 3 that would make my outside-inside add to 7. So it's got to be plus 1 plus 3 in that order. Once I have my factors, then I'm going to set each factor equal to 0. Notice I'm not going super in-depth with the factoring combinations, because the hope is as we've gotten to this point, we've gotten more and more comfortable identifying our factors, because once we get there, you can set each factor equal to 0, and the solving isn't terrible. But if you need more practice on the factoring stuff, you can look at our polynomials review, which has way more factoring in depth, or also just some previous examples in your notes or in this video. So once I have my two equations, I'm going to subtract 1 from both sides. So I get 2x equals negative 1, divide both sides by 2, I get x equals negative 1/2. And then subtract 3 from both sides. My second equation, I get x equals negative 3. And those would be my two answers for number 16. You could also use the quadratic formula there. You can use the quadratic formula for any quadratic that you solve. It's just sometimes that's not always the easiest or most direct method to get there. and that is a mix of solving by square roots, quadratic formula, and also factoring.